Hello, everyone. Welcome to the Golang Estonia meetup once again. And this time, we're gonna also record the event. So please mute yourselves unless you happen to be talking like me currently. And with questions, we're gonna do it so that when you get a question during the talk or workshop, then please use the uh, questions and answers panel on the right-hand side under chat in your Google Meets. So there's a chat, and then there's components, I guess, and then question and answers. Marco will give it a review every now and then, and these questions will be asked from Egon. And in the very end, there will also be a time for a question and answers just live. But so this time, it's the event takes place online, as you can understand. And it's about an introduction to Geo. And Geo is a package for cross-platform GUI building. We're going to have a intro or walkthrough of its functionalities by Egon, and also a live coding session where Egon shows how it's actually used. And Golang Estonia is organized primarily led by Marco and Egon, and there's some sidekicks every now and then joining the crowd. But what is Golang Estonia meetup group anyway? It's a community where it's a community by the community, for the community, whose goal is to build on top of itself whatever community we have already. So it's not only about who's the greatest programmer of all time, or who can know the internals of Go the best, but it's also just sharing our experiences and being there for each other every now and then. Our goal is to also give professional content like today, or any meetup where someone is giving either a talk or a lightning talk or a workshop like today. We also foster professional development, meaning that we encourage every one of you who are currently listening to this talk to get in contact with us, and why not become a lightning talk giver or a speaker soon for upcoming meetups. And we also support interaction with the experts, so it's especially works better, of course, in real time when we're in the same physical space as well. But of course, there will be Q&A in chat and later on with your voice as well. So that's your time to interact with experts. You should also get involved. There's a Go for Slack channel, or Go for Slack with the channel Estonia. Feel free to join that. We'll announce all the events there first, and then make it available to, or announce it also in the meetup page. Become a speaker, that I already mentioned before. Become a host. Now that the COVID numbers are getting more stable, and they have reduced quite a bit, we are now also thinking of starting to organize a physical event again. So if you're a company willing to share your nice venue with us, also sponsor some food and drinks, then get in contact with Egon or Marco especially. Become a sponsor. For example, you could also buy some nice swag for the speakers for their voluntary contribution to this meetup, or sponsor some raffles like books about Go, or why not a whole course from some website about Go to be distributed among some members of the community. And why not become a co-organizer? So join the organizing team. And other useful resources are also, we have a GitHub page where there's also meetup slides for previous events, and a YouTube channel where also this recording of this event will be uploaded. And that's it from my side. But I'll hand over Mike now to the star of this evening, who's Egon Elbre, and he will introduce the package Geo and does some live streaming for us. So let's give a warm welcome to Egon. And the floor is yours.
Okay, thank you, David. So I was thinking about doing a live coding session for Geo, but I realized that many people actually don't know how to use Geo or how to get started and kind of what are the basics of it. So for anyone who hasn't been using, doesn't know anything about it, so here's the elevator pitch. So here's an example program that some of the Geo community has been developing. So the first elevator pitch is that it's cross-platform. So you have all these different targets you can deploy it on. And it works pretty flawlessly to kind of compile for one or the other. It's immediate mode. I'll come back to that later. That's a way of writing UI software. And there are alternatives that aren't immediate mode. So also it doesn't contain Chromium or V8, so you won't get these slow or programs that take up 1 GB of memory to display one picture, which is unfortunately rather frequent occurrence with current UI development. Of course, it's still in development, so the community is still kind of fleshing things out and improving the visuals and support for different features. And I do recommend looking at alternatives as well, because there's no true one way of writing UI software. There's just a bunch of different bad ways of doing it, and none of them solve all the problems for you. Fine is a really nice one that has plenty of support and is native Go as much as it can. It uses OpenGL rendering as well. There's Nuclear, which has different backends for rendering. One of them, which is Geo, but it is a different option you can take. So there's, of course, you can use the usual bindings to Qt, or if you really want to do the HTML approach, there's Rails. There's HandLabs UI, which wraps the native UI components for different cross-platforms, which can be a really nice approach. However, you are stuck with native implementations. There's Walk, which is for Windows. There's Cocoa, which is for Mac. And of course, you can do some other tricks like using Flutter or native UI frameworks, and then just compile it for C, and then kind of call from the UI code that Go code. So these are alternative approaches, but today we're talking about Geo. I'm not saying anything bad about those, but they each carry their own trade-offs. So with good UI frameworks, there's a bunch of questions that you kind of need to handle. So how do you kind of detect that somebody moved the mouse, or when do you redraw the screen, or how do you structure your code to match what you want to be displayed? And of course, a bunch of other kind of these concerns. And each of those has like 5 or 10 different answers how to do it. And today, so we're going to talk about how Kia handles them. However, I think it's nice to give some teaser of different programs or examples that have been developed. So if you've been using Tailscale, then their Android application is using Kia. There's messaging apps Sprig that they have been developing. There's wallet implementation for those things, and there's a tracker implemented using Kia. This one I can easily show, like so. Yeah, like you can implement different things, and there's a recent example of mine or experiment for drawing diagrams. So there really isn't a limitation in like what you can do with it, but there's more of like how much effort do you want to put in question. So I think that's kind of all of the easy introduction about what Kia is. And if you want to follow along with the code itself, then there's this github.com/Golang Estonia/learn Kia. Marco can probably post this link into the chat. And yeah, we're going to take a look at different examples and kind of go through the things. For anyone watching later, some things may have changed in the implementation. So see what's in the repository that should be correct, and the video might be outdated at some point in the future. So what's immediate mode UI library? I think the easiest way to describe it is that it's a single flow UI library. What it means that is that usually you get something that happens on the system. So somebody moved the mouse, and then you get this input, and at the same time you render the screen and you update the button stages, for example, or you type more text into it. And that information, like what to draw and how to draw, gets sent back to the operating system and GPU and kind of all the other things. And it repeats until you have a nice working UI. And the important thing here is from conventional UI libraries, so retained mode, is that the state and how you render that state can be kind of separate, or however you wish to organize them. So whether it's more customizable to your own needs, however, this means you need to know what your needs are and how to what are the different approaches to do that. So in the repository, I do have this example here at the 0, quick start, and immediate mode that contains a really basic implementation of immediate mode UI, but using a console. Right, that won't work. Last example. So it will display this. So like this really simple terminal-based UI, and it's I would say a minimal immediate mode UI library example, or how to write one But since this isn't the exact topic for today, it's more of a thing you can explore on your own later. We're going to take a look at GUI. So the most basic hello world is looks something like this. What you see here is that we need to create a new window, and we need to start listening for events on it. So this is like grabbing the input from the operating system. As you see, there's this coroutine. This needs to happen because the main thread of the application needs to do other things. This is a requirement for UI frameworks on certain platforms because it needs to be running on the main thread. And roughly what's happening here, we're going to create a theme. We're going to talk about this later. We're going to lay out some text, and then we're going to render that output that we gathered. So it's might seem daunting at first. However, we're going to break it down into smaller steps, so it will make all sense, and you pretty much would be able to implement it yourself from scratch, the whole UI library in some sense. Of course, your production code, you don't want to have globals and you want to have different testing. And so in those cases, you might organize it a little differently. You might kind of have a proper type for the theme and handle the layout, the rendering code separately, and have different components for those different visual elements. So the examples are going to be in this walkthrough are going to be as minimal as possible to show the particular purpose. However, you may want to structure those differently for your own production-ready applications. And to simplify the code examples here, I wrote this really small wrapper that kind of does all that stuff that I showed previously, and it's going to just do as minimal as, but show as little as that boilerplate as possible. So don't get confused about QApp. Usually you want to use Kio directly, but these are mainly for showing example. Any questions so far, or feeling lost already?
At this point, no. But if somebody have any questions, then please put them in the chat or Q&A section in chat.
Okay. So starting from the basics, how do you get things on the screen? So I talked about how there's a loop of getting input and giving output to the system. So this is about how do you give output to the GPU to draw. So with Kio, there's two operations. One is to set the brush, which is kind of how you color an area, and then you say oh, please now color this. Unsurprisingly, this will just make a big red thing box, which isn't really useful. Of course, since we need to now do something more with this, we cannot just that's not even close to being a UI. We can add different operations to restrict the area where we want to draw or paint which area we want to paint. So in this case, it's going to set the area to clip to, which is clipping region is the area what you want to draw. So here's setting a rectangle, and it's going to paint it red. If you have multiple of them, they are going to be combined. So if I combine them together, it's going to be looking like that. If I do it this way, then it's going to it's going to add them together. Of course, there are different things you can do with those clip regions. One is to draw some shape, let's say some triangle. Internally, this is the way how text rendering is even implemented. Or you can use the path API to create some strokes. So, for example, if you're building some graphing library or visualizations, then you can draw lines. Nothing surprising here. You can, there are different functions to do curved lines or modify how you draw the ends of the stroke, for example. So here it's not round anymore, but there's a hard line there. Any questions about it? I guess not. Now, since there needs to be more primitives, one is for offsetting the image or the thing you're drawing. It's not much different from like HTML, Canvas APIs, and different other such things. And it's offset, and you can move things around. There's of course also some other things to rotate and do arbitrary affine transformations, but that's probably not too interesting for most cases. Now, I mentioned that having multiple clip regions and them together, one of the things you might want to do is now go back to the previous clip region or kind of reset the clip region you're working with. For that, you can use this save and load, which kind of saves the state of the rendering pipeline, which is the rectangle and offset and all of that. And then you can draw them, do these operations. Usually it's common to kind of combine these things into this into a single line with defer, and then you can draw two things without them interfering with each other. And then we can, of course, draw some images by using image operation, which is created by taking an image and like this paint.new image up, and it's going to draw that image to that specific place, and so just drawing an image. And finally, to now start to make something more interesting, is we may need to say to the rendering system that to redraw itself multiple times. Because if you're looking at here, then this the previous example here, you can see that it's going to be called only once. So if I resize, it's of course needs to re-render, but it doesn't kind of continuously re-render itself. To bypass that and to start making some neat animations, you can add this invalidation operation to the operations that the system needs to do, and you can kind of start having Gopher that tries to run out of the screen. Okay. So this is the first part of the system, like how you get things on the screen. The second part is going to be how you get input from the system. As an example, what you can then do is you can register yourself to listen to input events, so keyboard input events specifically. So this comes from IO key package, and you can then like listen input, and then do some things based on whatever key has been pressed. And in this case, it's going to be like just moving it around. You can, of course, get input from touch events, which is the pointer package here. Here I made an example for animating the Gopher to like go to that particular place and animate it. And of course, here we use the invalidate operation to redraw things and calculate how much we need to move and like figure out where to move. Directly using these pointer events can be like when you're writing a UI program can be annoying, in which case you can actually start creating yourself these different useful event processors that give you out some other events. So for example, there's this gesture package that contains for drag events. So you can listen for dragging and you can kind of move things around. And the same goes for button clicks, where you can listen to say that, oh, I want this this region of the screen to detect the button area, and then you can say that, oh, now I'm listening to button clicks. So, and now this pretty much looks like a button already. This isn't a really nice way to write buttons in a UI code, so you can try to simplify it. As you can see, when we take these, combine it into a single struct that has some area and tracking for the click and color and different states. And then we can wrap it into a nice reusable component, and we can do buttons. So works the same as before. However, as you saw that there's now a ton of these different things that we need to keep track of. What we can do is combine them into a single struct to provide to our widget. So now let's get to the meat of your library, I guess. This layout context contains all this information about like what is coming to that system and what operations are being sent out. It contains this constraints thing, which tells about how much space you have to draw. It contains this constraints min and max. So minimum says that, oh, you should draw at least this much. And constraints max tells the different widgets to how large you can really be. As for the button code, it pretty much will end up looking the same. So this is our custom button. Of course, since no one wants to write their own buttons, then there are buttons available. To draw different things, there's the material package, which contains material design or widgets with material design. To draw these material widgets, we need a theme. So something that keeps track of like what color things are. So for example, here I have inverted the default theme and got like black and white things. I can, or yeah, usually it's this way. And you use it this way, as you see, is that you get this layout context, which is for tracking like where to draw and the output what to draw, and each of the widgets will return this layout dimensions, which tells how large something is. So in this case, we create the header1 element with the theme and with this layout, with this text. And then we're going to lay it out, which means kind of drawing it. Some of these things can be cached. So for example, if I do this title thing here, I could provide it there and then later use it here. So it still works without kind of recreating this. If it seems weird to write it this way, then one of the concerns that this library takes is to make it as high performant as possible. Of course, you don't want something, or you want something nice for clicking. There's a button, like with the usual link fill as material designs have. One of the things that you might be notice here is that this widget clickable is separate from the material button itself. This is because the standard components or widgets in Kio separate the state of the item from the visuals of it. So this widget clickable contains everything you need to track whether something has been clicked and when it was clicked, and everything you need to draw those ink fills. However, it doesn't know anything about rendering. For that, there's this is the wrong file. There's the button code, which contains a bunch of arguments that, of course, you can customize for your own needs. And it has the logic for rendering this button and like the text inside and the background and everything. And to capture the clicks that happened on the click state, is you can then do log print line, like you loop over all the clicks that you got, and then you can print it. Of course, it contains a bunch of. You can, of course, read the exact locations where you got the clicks and all of that. But that's, I guess, for usually you don't care. As we saw before, you can have different text labels. You can, the font size is some other value, and it's by default. And text types. And And there are, of course, different ways of so there's the H2 and H3 and body 1, and like you get different size text that are convenient to use. There are other useful components, so editor, for example, so where you can type text and select text and like things you know and love. One of the things that you need to be aware of is that some of those this rendering is functional and some of this needs state. So, for example, here I had this editor outside of this layout function. So if I move this editor inside this layout function, one of the things that happens is this editor will be recreated for every render, which means I now cannot modify it anymore because it's resetting itself every time. With editor, it's maybe not as easy mistake to make, but there are a few other components where it's quite common to get confused about it. There are some sliders, and of course, there's a widget for image layouting, which can do the resizing automatically and all of that. So if I talked about in the drawing part of the system, then it kind of that the paint image operation doesn't do any rescaling for you. However, this widget image does have this fit and position to do the most common positioning. Any questions so far?
In chat, no, but how about other media assets like that, rendering video or other graphics, external graphics?
So there's no support video, unfortunately, yet at least. So there's still some work being done on the rendering engine, and I think there will be eventually something that allows you to stream images or things that are like it directly to the GPU. So you can try kind of, yeah, go ahead.
So what is the kind of maturity level of graphics engine, like how complex graphics you can actually kind of draw or send to renderer?
At the moment, so there's at the moment there's a compute-backed rendering engine going on, and that should significantly increase. So, like drawing a regular vector map should be completely fine.
But as far as I understand, for that point, it's also possible to kind of implement secondary renderers, right? For specific use cases.
There's a possibility to combine it with GLF, so the like GL windowing framework, which allows you to draw any OpenGL stuff, right? You do lose this cross-compatibility with it because I'm not sure how, I don't think it supports Android, iOS, and kind of different things, but you can start then drawing arbitrary GL stuff, which does include video. Does that answer the question?
Yes, yeah, you can go on.
Okay. Now that we have kind of different things to draw, we also need to draw them somewhere, which means you may want to kind of say, oh, I want this title to be centered, which is like regular centering. There are, of course, like northeast and different ways to positions you can put them. There's you can say that I want to inset different things if you want them to be smaller. There's stacking different things on top of each other. For example, if you want to draw some custom icon, in this case, there's a circle and there's a text inside of it, so which could be used as some icon on some chat application. Of course, you can do something. And of course, it's using the usual rendering, but this layout stack, which is a different kind of widget, which modifies this layout context to draw these different child elements on top of each other, in this case. There's the usual flex layout, which in this case I did header footer things. For example, I have an editor. I have this default inset to not touch this border, and then I can, as you can see, automatically when anything changes here, it will update this footer. But yeah, it's mostly you say, oh, I want to insert something and then draw inside of it this my custom thing, which is like flex layout, which is like from top to bottom. As you can see, this editor, it has been flexed. I could, for example, duplicate this editor to get like two editors that are exactly synchronized. And they keep their respective sizes. In this case, one of them is 2 times larger than the other. So if you want to put things beside each other without with them automatically scaling and not scrolling, then you can use layout flex. And there's lists that you can scroll, where you can kind of, it's usual scrolling thing. Here, what you get is these items. You say how many items you want to draw, and for each of them, you need to call this layout function to draw them. So one of the neat things about it is like I could, let's say I'll create, I don't know, let's create 10 million items into that score, into that thing, and it works completely fine without any effort, right? So it would take a lot of time to reach the end, but it's able to draw 10 million or to show 10 million different items. And yeah. And as a final kind of thing that you want to know is how you get asynchronous events going. I initially kind of threw away the main event loop where you get events. In this case, when you do expose it, what you can do is the usual Go way of getting input from multiple event sources or channels is to use a select. You kind of update some value and you say to the screen that you should redraw. So in this case, we get this counter thing that updates every second. So yeah. Finally, let's take a more practical example or more facilitated example. We have a button that counts things, which is usual example for UI programs. In this case, we're going to kind of create a structure to contain the UI state. So this is combining the theme and the counter. The counter itself remembers the count and has this like state for tracking this clicking status. One of the things that you can do for testing purposes is, let's say, make it public, and then you can like call this increase click to trigger the click event, and then relay out and see whether like this count updates. So you can test this UI code without needing to draw the UI. So I guess just the state logic changes. But yeah, in this case, we're using the flex to put them beside each other and center the text, and yeah, add some padding between those things. Yeah, and that's how you get to a counting pattern. Yeah, any questions about this example? Or is everybody completely lost already?
It would be good if you guys can put in a chat there any of questions really if you want to get some clarification of some topics, because we walk through pretty fast actually.
Yeah.
And if something is unclear also. And perhaps when you are right now on that state management, like then one of the things maybe to shortly mention is that like where would be the like most common and best way to keep your states, like cross shutdowns of the app, like since the UI itself is cross-platform, but how to kind of implement also the logic of the application kind of state management while it's restarted.
So you mean persistence?
Yes.
Right? So there are two things that you need to take account for. For example, if I added like some slow operations into the layout function, it's I say like 3 seconds sleep here. Anybody who's done UI programming knows that you don't put any slow logic into the event handlers. So if I kind of do this, then it becomes immensely slow, maybe too slow. Make it like 200 milliseconds, which is slightly better. So as you can see how it becomes laggy, because every time it does this function, it becomes slow. So there are few ways to handle, where there are infinite ways to handle it, to be quite clear. However, one common way is to do this asynchronously. So what you can do is you can set up a coroutine to run in background, and then similarly how this ticker event comes in, you can then kind of say that, oh, your file has been saved. Sometimes it might be just convenient to say, oh, when you click this button and you detect the click, you save the file, because often the save doesn't take more than 1 second, and like it doesn't matter too much if you slow the UI down. But yeah, it's more of a, do I want to make the extra effort to save things or not? And over time, I think there will be different ways of simplifying this, how to do asynchronous things with feedback to the UI. I have a few prototypes, but they haven't been, they aren't in the standard library yet. I'll show a few of those later. So to get to the example, so I have this game of life example, which does exactly this asynchronous logic. So I can draw here, and I can like do this game of life thing. And what it does, one of the things is this board is completely separate from rest of the UI logic. So this is the game of life. It doesn't care about any asynchronous behavior. And what the implementation here does is in the event loop, every time there's this ticker, it updates this state and it re-renders it. So this approach of doing other things while it's not rendering can be a nice way. So it doesn't use a coroutine to do this logic, however, it could. I have a different example for using a coroutine to it. It does, even if you kind of... So one of the things with this approach is that if you make this too slow, it would still affect the rendering, because it won't kind of slow the rendering itself down. However, it would make it so that the rendering doesn't happen as often, and like you can see, it still becomes like so this approach could be instead used to kind of spawn some coroutine and then get feedback. I won't go into the drawing of the port and like all of that stuff, because it's mostly things that you saw, just like more things. So in this case, this is kind of figuring out what's the pixel size and properly aligning the drawing and all of that. So it's not too interesting, I guess. And now we get to the example of doing asynchronous coroutine things or threaded things behind when something's happening. So in this case, it's this timer here that's going on completely in a separate thread, and I'm communicating it, resetting it, changing the duration on the fly, and doing different things. In this case, to make it happen, one approach is to like build this timer out of concurrent operations, so it can take you can update it reasonably fast from the UI thread. In this case, it has different operations to update the duration. It's currently using clocking. It could do like a channel send, and this could be in a different. It could have a different thread loop for itself. And every time this timer is updated, there's an event sent to this updated channel, which triggers this invalidation of the window. This invalidation of the window could be provided to the timer itself, so it like holds it by itself. But yeah, it depends on how you want to change it. And here in the layouting code, it will kind of change the values of the timer whenever the corresponding either the slider is moved or the reset button is pressed. And most everything else is about rendering the visuals. I'm aware that this kind of looks unusual at first. However, after a while you get used to it, and it doesn't look as annoying as the first time. So, and as I said about the different asynchronous loading, you can do something more advanced. So in this case, there's like it's loading in the background without blocking the UI thread. Like these things, let's say these could be images, and the red shows that it's loading, and or green shows that it's loading, and it's kind of doing this resource pooling and everything. So you can do more advanced things, and yeah. So yeah, this is the quick overview of Kia. and all the different things, how you would build up the your program, I guess. This is more of a guide, like how to do everything here. And if you do get stuck, there's a Slack group #Kio that where you can ask questions, and yeah. So that's the quick overview of the whole Kio as it is.